Section 13.2, the meaning of logarithms. So let's recall 2 cubed is 8. Therefore, I can go sort of in the reverse. Therefore, the exponent of 2 that yields the number 8 is 3. So we say that the log base 2 of 8 is 3. Similarly, 3 squared is 9. Therefore, the exponent of 3 that yields the number 9 is 2. And so a logarithm is the exponent of some base that yields the value. And so it turns out that a logarithm is just the inverse function of an exponential function. Since the exponential function was either always increasing for the case of the base being greater than 1, and it was always decreasing for the base being between 0 and 1, then I have that that the exponential function is a one-to-one function. That this is one-to-one, is one-to-one. Therefore, it has a inverse function. Implies that the exponential function has an inverse function called the logarithmic function. So the logarithm is really just the inverse of the exponential function. So the logarithmic function. So let's assume here that the base is greater than 0 and not equal to 1. Then I'll define the logarithm function as follows. The logarithmic function f of x, or g of x, let's say, and I'll denote it by log base b of x is the inverse function of the exponential function y equaling f of x equaling b to the x. So it's the exponential function with base b. Okay, and so we can see that the logarithmic function has, well, let's see. looks like this for base B between 0 and 1, intersects the x-axis at 1. And so it is always decreasing. It is concave up. Hmm. It is, so it has no horizontal asymptote. But it has a vertical asymptote of the y-axis, and this is for values of x very small. It has increasingly larger and larger values of x. It has no y-intercept, and it has the x-intercept (1, 0). Again, this is corresponding to the exponential function having a y-intercept at 1. Similarly, if let's say there, say that this is y equaling the log base b of x, where b in this case is greater than 1. Then the logarithmic function has a graph looking like this. And so it's always increasing. But it's concave down. And it has no horizontal asymptote. Of course, these are all smooth. There are no corners or breaks or anything. And it has a vertical asymptote of x equaling 0. It has no y-intercept. And it has x-intercept of 1, 0. Okay. Let me give you some special notation. The common logarithm So when Napier actually invented the logarithms, he did this for base 10 because, well, that's the natural base that he was working in, is base 10. That's what we uh, have our numbers. Uh, we count base 10, etc. And so the notation for that is just log. So if you don't see any base, the base is assumed to be base 10. So on your calculator, you'll see it just has a log button, and, well, that's just log base 10. The natural logarithm is actually denoted by ln for natural logarithm. It is a logarithm where we assume that the base is base e, where e is that number we introduced in section 13.1. So let me do, let's say on page 549, let me do problem number 4, log base 3, 81 equals 4. In exercises 1 through 20, rewrite the logarithmic statement as an exponential statement. And so let's rewrite this as a statement involving exponents. So notice that the base here is 3, the exponent is 4, and the result is 81. So this logarithmic statement, log base 3 of 81 equals 4, just says that 3 to the 4th is equal to 81. Let me do problem number 8. And so 8. Log base 2 of 1/8 is equal to negative 3. So this says that the base is 2, the exponent is negative 3, and the result is 1/8. And so log base 2 of 1/8 equaling negative 3 is the same as saying 2 to the negative 3 is equal to 1/8. Let me do problem number 12. Log base 27 of 3 is equal to 1/3. So this is the same as saying that 27 to the power 1/3 is equal to 3. The base is 27, the exponent is 1/3, and the result is 3. Okay. We can do problem number, let's say 22. 4 squared is 16. In exercises 21 through 35, rewrite the exponential statement as a logarithmic statement. So the base is 4, the result is 16, and the exponent is 2. So log base 4 of 16 equaling 2 says that the exponent of 4 that yields 16 is 2. 4 squared is 16. 30. 4 cubed is 64. And so this is the same as saying that the base, so the base is 4, the result is 64, and the exponent is 3. And so log base 4 of 64 equaling 3 says that the exponent of 4 that yields 64 is the exponent 3. 4 cubed is 64. Let me do problem number 34. Cube root of 8 equals 2. And so this is the same as 8 to the 1/3 equaling 2. A cube root is the same as an exponent of 1/3. And so this is the same as saying that the base is 8, the result is 2, and the exponent is 1/3. And so log base 8 of 2 equaling 1/3 says that the exponent of 8 that yields the result 2 is the exponent 1/3. So 8 to the power 1/3 is 2. The cube root of 8 is 2. Let me do problem number 38. G of x equaling log base 1/2 of x. And so y equals log, well, I'll just graph it. So let's graph this. In exercises 36 through 50, sketch the graph of the function, give the coordinates of the x-intercept, and the equation of the asymptote. Okay, and so the base here is 1/2, which is less than 1. So it should look something like this, where we intersect here at 1. So this is the graph of y equaling the log base 1/2 of x. And so let's find the x-intercept, which of course I know is 1. To find the x-intercept, I replace y by 0. And solve for x. So let me rewrite this as in exponential form. So the base is 1/2, the exponent is 0, the result is x. Well, 1/2 to the 0 is just 1, so x is 1. So therefore the x-intercept is at 1, 0. Let's find the vertical asymptote. So the vertical asymptote occurs when this logarithm is undefined. Well, this logarithm would be undefined when the what's inside the logarithm is 0, because we can see that any base to a power cannot equal 0. So therefore, we can't have 0 inside. And so the vertical asymptote occurs when I set what's inside the logarithm to 0, which in this case is x. So the vertical asymptote is at x equals 0. Let me do problem number 46. F of x equals log base 3 of x minus 2. And so this says that y equals log base 3 of x minus 2. So this is actually a translation of the graph of y equal log base 3 of x. And you're going to translate this in the positive x direction, so to the right 2. And so let's do that. And so the log base 3 looks something like this. And I'm going to translate this 3 units over. And so the graph should look something, well, actually let me move the x-axis over 3. So let's say this is x equal 3. So then the graph should look something like, so this is a graph of y equal log, 2, not 3, 2. Move it over 2. Log base 3 of x minus 2. So let's figure out what the asymptote is. I already know what it is. And the x-intercept. So let's do the x-intercept, I guess. That's what I did first. Yeah. Let's do the x-intercept. To find the x-intercept, I replace y by 0 and solve for x. So let's rewrite this as a exponential in exponential form. So the base is 3, the exponent is 0, and the result is x minus 2. 3 to the 0 is 1. Add 2 to both sides of your equation. And so x is equal to 3. Oops. So x is equal to 3. So it says that the x-intercept is at 3, 0. So this is at 3. And let's figure out the vertical asymptote. Found by setting what's inside the logarithm to 0. Add 2 to both sides of this equation. And so this is the vertical line, x equal 2. You must write, of course, a vertical line in the form x equals something. Let me do problem number 50. F of x equals -2 plus log base 3 of x minus 1. So let's rewrite this as y equal -2 plus log base 3 of x minus 1. Add 2 to both sides of your equation. So you get y plus 2 equals log base 3 of x minus 1. And so this says that I'm going to translate y equals log base 3 of x. And this will be to the right by 1 unit and down 2 units. Okay, so let's do that. So let's sketch a graph of this. So log base 3 of x, well, we just did it. There's log base 3 of x. So let's do the same thing. So this is the log base 3 of x. And so I go to the right one, and I go down 2. Okay, so I'm going to do that. So I'm going to go to the right one. Let's say, And I'm going to go down 2. Okay. And so it's going to look something like that. So this is a graph of y equaling -2 plus log base 3 of x minus 1. Okay, let's figure out where it intersects. Of course, we know that this line is x equaling 1. This is y equaling -2. Not that that matters. And so let's find the x-intercept. And so let's replace y by 0 and solve for x. Add 2 to both sides of your equation. Two equals log base 3 of x minus 1. And so let's rewrite this in exponential form. Oops. Let's rewrite this in exponential form. And so I have here the base is 3, the exponent is 2, the result is x minus 1. And so 3 squared is 9. Add 1 to both sides of your equation. And so x is equal to 10. So I guess this point here is 10. So I have here 10, 0. And let's find the vertical asymptote. Found by setting what's inside the logarithm equal to 0. Add 1 to both sides of your equation. So x is equal to 1. So x is equal to 1. So that was problem 50. So I guess that's it for section 13.2.